Quiet, please.
Let's finish. I see some of you still sorting some issues back there, Master. But as I was mentioning, today we'll talk about Nextflow, which is a workflow orchestrating framework that allows us to build pipelines to enable us to conduct analysis in a reproducible manner. So by the end of this brief theoretical introductory course, as well as hands-on experience, we hope that you will be able to understand what a workflow management is. You will be able to understand the benefits of using a workflow management system, and also explain the benefits of using Nextflow as part of your bioinformatics workflow, and be able to explain the components of a Nextflow script, and ultimately be in a position to run a Nextflow script. So just to give us some background overview on why we implement workflow management systems is that it has been largely driven by the concept of open science, which is basically a framework that calls for making science more accessible, more inclusive, and equitable to the benefit of all. This is according to the UNESCO definition of open science. Some of the critical aspects of this open science are enumerated here. We have open data, which ensures that data is freely available and adheres to the FAIR principles, that is findable, accessible, interoperable, and reusable. Open science also calls for open access publishing, whereby peer review, there's open peer review, allowing the accessibility of these research materials. When you publish, you are able to freely access whatever has been published. Open science also embodies open source, which is a framework that allows us to share code freely for inspection, modification, and improvement. And finally, open science also is embodied by open peer review, open notebooks, and open standards, all of which enable us to be able to reproduce or replicate what others have done. Now, one of the major components in open science is reproducibility, or being able to replicate what other people have done. In this illustration by Yang Min, they give an illustration on how reproducibility can be a challenge in science. You see here, you come across a very nice publication, and in the methods section, they just give you a tip of what underlies the entire method section. So it's like a tip of the iceberg. Down the ice, you see there's language, the programming language which we use, the versions of the operating systems, the file formats, readability, metadata, availability, and all the references. But in the method section, often we only see a tip of what underlies the exact method. So you might be in a position to replicate whatever those guys have done, and you bump into a problem. So it's always important to ensure that whatever the steps that you have undertaken in your analysis are reproducible, or someone else can be able to replicate. So what are workflows? So essentially workflows are a series or a sequence of steps that allows us to do data gathering, cleaning, and processing the data. So often this series of tasks is what constitutes a workflow or a pipeline. In this image, we show a workflow that was developed for annotating parasite genomes. And you see the numerous steps that are being undertaken in that entire pipeline. So what you're talking about here is this series of or sequence of steps or tasks that are being done constitute what is called a pipeline or a workflow. So this brings us to what is a workflow management system. So basically, a workflow management system is...
Sorry, if I can interrupt, John. So do we still have the power problems here, or was it fixed?
No, we can't. Like,
Which one is off?
they're all
This is off. Oh, wait, and now you've made it all go on one circuit. Okay, now you're steering. Okay, but these two ones at the back are off.
Yeah, so I'm rerouting all the power to the front.
So these two, and then this one that is on is plugged in. Oh, you're plugging it in from there.
Yes.
So all the everything on the floor is off.
Yeah.
Okay. Okay. Thank you so much. Okay, so the debugging is common, but all of this came from one plug steering as well.
Sorry for the interruption. So anyway, I was talking about what a workflow management system is, and it's basically a data orchestration framework that allows us to integrate the software that you're using, the data, and the steps in a manner that can allow us to monitor, execute, and share all these pipelines with other people. So some of the components of our workflow management systems are listed here. Number one being runtime management. So essentially means the management of a program execution on the operating system and splitting the tasks and data to run at the same time in a process called parallelization, or what is called parallelism. Workflow management systems also allows us to manage the software that you're using. As you've learned previously, we have numerous ways how we can manage softwares and dependencies. We can use Conda or containers such as Docker or Singularity. And so workflow management systems integrate this software management to enable you conduct your analysis. Workflow management systems also have what we call portability and interoperability, meaning that whatever I am able to run locally on my computer, if I share it with you, you should be able to run it. Or if you want to run it in a cluster or a high-performance computing environment, you should be able to run the same workflow and give you the same results. Reproducibility, which I mentioned previously, is that I am able to replicate whatever others have done. And reentrancy, or as we shall see later on, is the fact that these management systems have a system of resuming where an analysis pipeline stopped. So for instance, you are running a pipeline which takes 30 days, and somehow you notice there's a bug in your script. You won't have to rerun the pipeline from scratch. In theory, that is what is expected. But when you use this workflow management systems, they are able to resume from where they stopped. Okay, so that's what we call reentrancy. And this now brings us to Nextflow, which is a data orchestration framework that allows us to integrate all these components of a workflow management system so as to be able to run reproducible kind of analysis. So Nextflow in itself is a language. It's a domain-specific language, or what is called DSL. Just like we have SQL when working with databases, or awk when we're trying to process text, as we have seen in Unix. Nextflow is a domain-specific language, just like these other languages that I've mentioned. And it's built on top of a Groovy programming language, which is, I think, a superset of the Java programming language. So it allows us to give us Groovy syntax for controlling how our analysis is run. So the approach which this simple DSL Nextflow uses on top of a more powerful general programming language such as Java allows Nextflow to be flexible so that you can be able to handle cases which may be difficult to implement when using DSL alone. Now, one of the major improvements in Nextflow has been the implementation of the DSL2 syntax, which makes it more powerful in terms of handling modules. So you can imagine that you've written a script and you want to reuse a component of that script in another process. So DSL2 enables you to ensure modularity. And this is very useful when it comes to how you manipulate your data and also the readability and reusability of these modules in other workflows. You can simply invoke this in a Nextflow script when you, is there a pointer here?
I can go look for one. You want like a laser pointer?
Yeah.
Okay.
Yeah, but basically you can invoke this functionality of DSL2 by typing nextflow.enable.dsl is equal to in your Nextflow pipeline, or when you're running it from a command line, you can just use the option -dsl2, as we will see later on in our hands-on practicals. Now, Nextflow has three main components. We have processes, we have channels, and the workflow itself. So what is a process? So a process is basically like a function or a task. When you're running, for instance, you have, I'll illustrate in the next slide. It's a task. You are, like in the first session, we were manipulating the text data on case data from, which country was it? Haiti, yes. So you were splitting that data and extracting columns. So the process there is splitting the data and extracting columns that you're interested in. So for instance, you extracted maybe column 5, which had either male or female as gender. So that would constitute one process or one task. Okay? Similar to what you do in your bioinformatics analysis. Once you get your read data, you want to run some quality checks, you run fast QC. So that is one process on numerous files. The next step would be probably to pre-process that sequence data using tools such as Streamomatic or FastSpeed. That will constitute another process. So a process is essentially a task. And these tasks can be manipulated in any language, any scripting language that you are familiar with. You can use Python, you can use Perl, you can use Ruby, or even the Bash in itself. Okay. Now, channels describe the flow of data through those processes. So we have, for instance, you are processing raw reads using FastQC. So your channel there, your input channel will be the raw reads, okay? And the process will be running FastQC, okay? And the workflow now describes the entire process that your pipeline is doing. So once you have listed all the processes or all the tasks, FastQC, FastP, maybe you're doing RNA-seq, you've done quantification, and then there's a workflow block which now will undertake all those steps that you've listed as your processes. Here is an example of what a process and a channel is all about. Okay, as I was mentioning, you have your samples. So these are your reads, right? Maybe you have 3 samples, and the process is running FastQC. Okay, we've said the process is a task. Okay, so this task, it's not one. This task is going to be performed on all these 3 samples. Okay, so you will have an output channel that also emits 3 different outputs. So this is the input channel, this is going to be your output channel, and you can take this channel to another process or another task which will perform a different process that you want. And finally, you can also have another output channel. So processes are the tasks, channels is how you manipulate the flow of data through those processes. Now, when it comes to execution, Nextflow allows you to execute all these processes using different executors. You can execute it on your local computer, on your local machine. You can execute it in cloud platform. It has the ability to integrate this in a cloud environment. or you can execute these processes in a high-performance computing platform, or HPC. So here's an example of a process execution block. As we've said, to enable it to be compatible with the most current syntax for Nextflow, you use the key word nextflow.enable.dsl is 2, and then you will define a process. So process here is a keyword, and then the name of the process, maybe fastqc. Okay, the name would be fastqc, and then you will include directives. So this will give directions on how you want the process to be run. For instance, you wanted to use this certain number of CPUs or threads. You indicate that using some keywords which will learn. You wanted to use a conda environment. You give it the conda package it requires, or you want it to run in a container, maybe Docker or Singularity. So those will come under the directives block. And then you have your input. So the input here is the input channel, okay, which you will have defined somewhere from maybe your raw data. You have the output. The output will be the output channel, the elements that you want to be in your output channel. You can also use conditionals. For instance, when your raw read data is single-ended, then do this. If it's pair-ended, you take a particular task. And then you have the script, the shell or the execution block, now which actually runs the command that will incorporate all these components. Is that clear? If something is not clear, please feel free to raise your hand. But I think we will get to have a feel of this once we start the hands-on tutorial or training. Here's another example. Now, this is an example with all these different blocks named. So this is a Nextflow process block that allows you to perform indexing. So you have your genome or your transcriptome, you want to index it. So the process is called index. It's using 4 CPUs, and the input is a path to that transcriptome file, okay? The output is going to give also a path, which is going to be named Salmon Index. So by now you can guess it's using a tool called Salmon, for those of you who've done RNA sequence data analysis. And the script itself now will execute the command that will run this process of indexing. Okay, Salmon Index, the number of threads is going to pick from the directive here, which you gave us 4 CPUs, and then the -T option will give the path to the transcriptome, and the output will be the index, which is the Salmon Index. It looks simple, right? And quite straightforward. So as I say, Nextflow also allows you to run your scripts or your processes using other programming languages. If you're good with Python, then you can just write a Python script and execute it within the script block of your Nextflow pipeline. Okay, here's an example where you are implementing some process called PyStuff, and basically you are implementing it using Python, and you want to count the number of reads in a particular read data. So with Python, you need to import the required packages or libraries. You import gzip. This will enable you to open the zipped file and then read the contents of it. Then you can use your for loops to count the number of reads as well as count the number of bases, and finally present this as a standard output as the number of reads and the number of bases. So as I was mentioning previously, you have your processes, but now for you to run the entire pipeline, there is the workflow block now which will list all the processes that your pipeline is undertaking. So in the workflow block, now you list all the processes that are in your pipeline. Yep.
Can you biological and maybe also present very first line is that commented out.
Yeah, this is a comment. So in Nextflow, the comments are like, is it backslashes or forward slashes? I don't know. The backslash, yeah. Yes, so in Nextflow, you comment using these two backslashes. Yeah. Yeah, so it's just a comment, so there's nothing going to happen there. So, yeah.
What apart from Python script, what other scripts that
You can use your Perl script, you can use Ruby, you
How
can
do you indicate that script before you start the line? Or you just recognize the kind of scripts you use?
yeah, so before you have to indicate what Peter mentioned. So if it's a Python script, then you have to indicate that it's going to use this interpreter. The script is going to be integrated using Python. So it's a Shebang line, which Peter talked about in the first session. Yeah. Yeah. So how do you run a script? So you've written a script, and normally they end with the suffix .nf or the extension .nf. So basically you invoke the Nextflow command, and then there's a sub command with the Nextflow called run. So Nextflow run, the name of the script, and if you have any options or parameters that you're including, you incorporate them. Okay. For instance, when you are doing the indexing of the transcriptome, you would simply do Nextflow run the name of your Nextflow script. And so basically, Nextflow is a very powerful tool that allows you to integrate different programming languages within your processes. So you can incorporate R, Python, Bash scripts in your processes. It has the ability to support numerous software management packages such as Conda, or containers such as Docker or Singularity. It also has an inbuilt component that integrates it with software version control such as GitHub, GitLab, and all that. And it also supports numerous compute platforms. You can run your pipeline on cloud, you can run it locally, you can run it on HPC. And all this makes Nextflow a very powerful data orchestration tool. So back to channels. I think this is where most people have challenges. So a channel, as I mentioned, is a way on how you dictate the flow of data through the processes. Okay, just look at it from this image here. You have this task alpha, which emits these outputs, file z, y, x, and then it passes on to another task beta. So one thing you need to understand here also is that these channels are asynchronous, so they are not, the outputs may not be necessarily in the same way they came in the order they were given to the task or the processes. So you can have file Z, Y, X, but the order in which they will come out after particular processes may not be that. The order may change from X, Y, so that's what we call implicit parallelism, which is very powerful because all these tasks are being done concurrently. Okay, so the order in which they get in may not be necessarily the order in which they get out. Okay. So Nextflow has two main channel types. The first channel type is a queue channel, whereby the data is consumed or used up to make input for a process. So some of the methods of these channels, you can use channel off or channel from path if you're having a directory that has your read data. You can simply use channel from path, and if they're paired end data, you can use channel from file pairs. So they're called channel factories. That channel factory will be is intelligent enough to see that the pair end, and then it will group your data in a manner that is consumable to the process which you're giving it. So we also have value channels. So these are just single value channel. If you have a number or maybe a path to one particular file, then you can use that. So the other important thing that we can see here is that DSL2, which is a new syntax for Nextflow, allows us to use queue channel multiple times. So as opposed to the initial syntax, which only allowed us to use a channel one time within our workflow. So you can define a channel within in DSL2, you can define that channel and then use it multiple times. Okay. So as I was saying, this channel factory are listed here, especially with queue channel factory. We have channel of, channel from list, channel from path, file pairs, and from SRA. You have a list of your SRA IDs. Maybe you want to download the data, you can simply use channel from SRA using those IDs that you provide as an array or a list. So here's some examples. Channel value, this is a single value. So this is a value channel. It will emit only one. Channel value, you still have another list of values or variables. And this will give you also an array or a list. So we're just running through how, or examples how you can use these channels in your script. So channel of still the same, but now the output is not an array or a list. We can have a channel of again, and then we can incorporate what we call operators. So operators allow us to manipulate the channels. So you have two channels. One is a channel of maybe A, and the other one is a channel of some numbers or digits, and you want to combine or mix this. Then you can use this mix operator, and it will give you a channel that has the digits and your number. So how you invoke that in a Nextflow is just to take the, yes? There's a question? So how you do that is simply take the first channel and you use the operator called mix to incorporate the second channel, and then you can use another operator called collect, which will now convert the channel into an array or a list. Okay.
So it's that specific for a given channel type, or it can
so mix
can wait on both queue or value channel.
So these operators mix and collect can work on any channel type. Okay. They're not specific to one.
You can combine queue and value.
Yes.
For example, you can mix queue and value.
Yes. Yeah, true. And then again, you have this part where you have your row reads and you want to list all your read data. You can use channel.fromPath. But in this case, you are ignoring whether they are single end or pair end. If you want to be more specific, then you can use this, the second option, which is channel.fromFilePairs. And then you use this globe functionality that allows us to take files that have either one or two, and they're ending with .fq. And you can also add another option, which is size, to indicate for every file you need to the size of, so it's paired, and in other words. Okay. So the use of these globe operators in Nextflow enables you to, it saves on time, because you won't go trying to manipulate your data to look in such a way that it's compatible maybe to your previous script which you are using. So Nextflow really makes use of these globe operators to help you build these channels.
So just go back one please, John. So that from path is going to give you a list of pairs, right, in the channel, because it's got the 1,2.
Yes, it will give you a list of pairs.
And is that? And I noticed that syntax, that glob syntax, is not exactly the same as shell glob syntax. So that's a specific Groovy or Nextflow glob syntax, the one where you use curly brackets to separate the options.
So for Unix, you would have to
That in Bash would read star underscore square brackets.
Yeah, square, not the curly braces. Yeah.
Yeah, so it's a Nextflow pattern. I think
Yeah.
if you Google Nextflow patterns, you'll find it.
Yeah. That it uses the globe thing. You can also filter to your channels when you want only your channel to have numbers. Use the operator called filter, and it will only give you numbers or digits. You can do further transformations. It's a powerful operator called map, which allows you to put in a function of your choice that can allow you to manipulate whatever is in your channel. So in this case, you have this channel which has, I think this should be CHR, the first one. You have chromosome 1 to 4, and you want to replace all these items in the channel. You want to replace the string CHR with nothing. Okay, so map will easily do that for you. So with map, you give it any function of your choice, and it will do whatever you want it to do. There's another operator called flatten. So you have an array, your channel is an array or a list. What flatten do it will separate all these components in your channel and give them as separate entities of the channel. Collect, as you said, probably is the opposite of flatten. You have a flat channel. You want to collect, it will give you an array of that channel. It's the opposite of flatten. You can do an operator that counts the number of items in your channel. So the operator there is count. So I think these are some of the important DSL syntax that Nextflow is using to make it a powerful tool when it comes to your data analysis and data manipulation. Yeah, so I think the major highlights of the milestones in Nextflow, I think, would be the introduction of DSL2. When was that done? In 2020, DSL2 syntax, which is more powerful, allowing you to reuse modules or modules in your Nextflow script. And then the other milestone was probably the use of what we call NF-core. So NF-core is a set of tools that gives you the advantage of reusing modules that have been built by the Nextflow community. So there is quite a range of modules that you can use. You don't have to write a module running in a script from scratch. So this has already been developed, or you don't have to reinvent the wheel. So these modules are available. What you need to do is just download the NF-core tool and then use the NF-core modules to download those modules, integrate them into your pipeline. You don't need to write anything from scratch. Most of these tools have been developed. Yeah, I think up to there, is there any question? What time do we break for tea? Well, it's too early. We can go on, right?
Yes.
Okay.
So just sorry, I've got, because I'm so NF-core. Just I think it's worth discussing it a little bit more. So NF-core is like at least two different things as far as I can tell, right? It's actually three, or maybe more. But NF-core is a collect. So the first thing is, So maybe like, so if you look at the earlier Nextflow pipelines, for instance, the one that you wrote on the Rift Valley virus, when it was the Nextflow is written in Ruby, which means that there's no early pipelines. There was no standard way of providing input, right? So in other words, if you look at like the one that Tom Connor's lab made for SARS-CoV-2, Arctic INCOV 19, whatever it was called, I can't remember the name exactly. It expected your files to be in some directories and something like that. Okay, other person would do a different thing. Okay, there's all sorts of different, like, because there was no standard way of doing interfaces. Okay, so NF Core, when you start an NF Core project, I think every project uses the same input template, or basically like there's a standard start that it all looks the same, right? And one of the things about NF Core is that basically everything is now assuming that one of your major inputs is a tab separated value or is a comma separated value, but it's a tabular file.
It's common.
Is it comma? What's it? Comma. So it's a comma separated value file where it'd be like sample name, read one, read two, etc. So instead of, because one of the problems in command line bioinformatics has always been must I organize my file names like this? A lot of the tools have like basically assumed you're going to have this, the name pattern in your file names, or they're going to be in this directory structure and things like that. So NF Core has done away with that and said you can have your files however you want, so long as you give this sample sheet file, which the samples must be identified by like this thing. And all, as far as I know, all NF Core pipelines follow that same thing.
Yeah.
Okay. So like, there's other options. So like, for instance, maybe using bow ties and mapper instead of BWA or something like that. There's different options. But the main thing is that there's the standard tabular format of inputting like your data. Okay. So that's the one thing about NF Core. And the fact that it gives the script author consistency. Okay.
Yeah.
The second thing, as you say, is the module system. So they've made, so like older NF Core workflows were like one file and everything, like you would just get this main.nf, right?
Yeah, main.nf,
and it would basically be like almost like a Python script, but now in Ruby, but like it would be just like a script. And like, if you wanted to change anything, it was hard, right? You want to change your mapper from bow type to VB map, then you have to go change some code. Now with the module system that you're describing, NF Core people, they make one module for BWA, they make another module for Snippy, they make another module, and then everybody can reuse those modules and they get updated and all of those things. So that's the second thing. But then the third thing is that then there's a tool that you mentioned, right?
Yeah.
So there's a command line tool for doing doing lots of tasks. And it does a lot of things. Like one of the things that it does is if you're going to use containers, like normal Nextflow, while you're running the script, the first time you're running the script, it will download the container. Okay. But now what if your internet's not great, and your internet crashes halfway through running the script, then it's a problem, okay? So the NF Core tool, one of its commands is download. So it will download the containers. You just tell it, this is my NF Core thing, and my NF Core compliant workflow, and then it downloads it like for you automatically. And then of course, this is not even counting the fact that the NF Core project also has its own standardized workflow that they maintain. So we're just talking about all the tooling that they provide, but they also have like viral recon. It's maintained by like a whole community. But then the last thing, and it's probably not relevant for a lot of people here, but it is actually really nice, is that when you're running, if your infrastructure is more complicated, right? Like maybe you've got access to an HPC cluster, or you're running on Amazon or Azure Cloud or something like that. Okay, just as a matter of interest, who here has a high performance computing cluster at their home institution. I know you've got one, so it's like you've got HPC, and you guys have an HPC at Noguchi. And I know that, like, for instance, in Panga, you guys have a server, right? You've got a server at ZNPHI.
Yes.
But it's not an HPC yet, but it is like a bigger server, okay? And then other people, like, have other computing. I mean, you guys still have a cluster at ILRI?
Yeah.
You know? Okay. So you've got access to their one. And we've got here, do you guys have a cluster here? You got a cluster? So, but clusters can have different configurations. Like, some people like are using PBS scheduler, other people are using slope scheduler, things like that. So NF Core lets you actually, and Nextflow lets you to configure, this is how to run jobs on my cluster. Memory limits is this, all of those kind of things. NF Core lets you, as an institution, actually add to the configuration so that your users just need to say minus profile and the name of your institution, and it will configure how to run your Nextflow at your institution, which is pretty awesome for, like, if you want to make your users' life easier. So there could be so Stanislas could make a configuration for Institut Pasteur de Côte d'Ivoire. Okay, you could make like a configuration, then all of your, let's call it IPC or whatever you want to call it. Then they will just say Nextflow run minus profile IPC, and it will get all the right settings to run on your cluster, and the users don't need to know about all of the ins and outs. So that's also maintained by the NF Core project. So, like, without the NF, so NF Core is not, Nextflow is run by a company, but NF Core is run by volunteers, right?
Yeah, it's a community.
Yeah, it's a community. Oh, and the last thing, of course, is that a lot of the training is being driven by NF Core, not the Nextflow company.
Yeah.
So, the NF Core thing, if there wasn't NF Core, Nextflow would be half of what it is, would not nearly as good as what it is.
Yeah.
But anyway, so these are some of the extra features that the NF Core thing gives you. That is the NF Core command line tool that you've got,
Yeah.
which you can install using Conda, right?
Yeah, sure. Yeah, so there's more to this. I mean, this was just touching the surface of it, but as Peter's mentioned, there's pretty a lot of developments in terms of NF Core and Nextflow. So, yeah. Yeah, so what we want to look at also is what is called the Nextflow Tower, developed by the Secura guys. So Secura is just an OpenStack platform that has allowed institutions and researchers to perform data analysis in a reproducible and in an accessible manner. Okay. So this thing called Nextflow Tower is an open source monitoring and management platform for Nextflow workflows. It is developed by Secura Labs. There's a community version which is installable, also the command line to your computer, but they also have an enterprise version which gives you more resources in terms of compute resources if you want to run your pipeline in cloud-based kind of environment. How many of us have used Galaxy? I would think it's more or less like Galaxy, yeah, because you can. It's an easy to use platform, so it has this page that even if you don't have any programming or scripting language, then you're able to easily run your pipeline. Okay. It has this intuitive interface that is also user-friendly. All you need to do is create an account with them, or log in with your Gmail or your GitHub account, and then it has a list of pipelines which you can run on the platform. So why this platform? So it improves productivity because Nextflow gives gives us a unified view of data, processes, and the compute resources, and this can enable us to collaborate effectively with our colleagues within our institute. It also reduces costs because it optimizes the compute and the storage costs. It removes complexity, and the platform has been tested in terms of compliance and security, and it has passed all these requirements, for instance, by the Health Information Trust Alliance. Okay. And it's also largely driven by community pipelines, as Peter had mentioned, the NF4 community, which has so many pipelines that one can reuse. So if you submit a job or you submit your pipeline to run on this platform, you can easily monitor it in real time. So it gives you more control in terms of how you launch, how you manage and monitor your work. Just like Nextflow, it also incorporates other compute platforms such as SLAM, SGE, and it also supports cloud computing. It also incorporates container technologies, Docker, Singularity, and biocontainers. It also gives you a way to integrate your pipeline with Git versioning tools such as GitLab or GitHub. Yeah, so that was just a surface of what Nextflow is. I think the juicy part will be when you start.
Same one, but you just skipped over the bit that, so you're talking about the free tier of Tower, right?
Yes, yes.
Because, so some people have got by with the free tier, and I've heard it works quite well. But if you have to pay for Tower, it's like super expensive.
I've never used the enterprise, so I don't know.
So are you using the free tier of Tower at the moment?
Yeah.
Okay. And you found that it gives you enough compute for what you are doing?
On small data sets, I don't use it more. Just
Okay.
So
Nextflow Tower is run by a commercial company, and they do have a free tier, and some people have told me that it's enough compute for them. But if it's not enough, the enterprise tier, I mean, I know some American labs that can't afford it. Cannot afford it. It's that expensive, you know. But it does give you Tower up to. It's like what is this model that they call it freemium, that you get certain things for free and then beyond that you pay. So some people it works, some people it doesn't, depending on what your problems are. But like a lot of our patterns and work is kind of small, so maybe it will fit. I think they're planning to make their real money from the people in the pharmaceuticals industry with their human data and those things. But yeah. But just to point out that like Tower is a commercial product at the end of the day.
yeah. Okay, so within Nextflow there are also a couple of training opportunities. I think in a year they normally have like 2 trainings, one in March, one in October, and they have also hackathons where you can take part in to develop these NF4 modules. They also have mentorships where they pair you with a mentor, a more senior guy or an advanced guy who uses Nextflow, so as for you to be able to learn more. So I'll put the links, and this material should be available on the course website, right? Yeah. Yeah. So here we're going to try some hands-on exercises. I don't know what Tony, what time for break or?
We can do it 10:30 if that works for you.
Okay. Yeah, so go to the training website, and on the last, on the Nextflow content, so let me change. Yeah. Should be hands-on here. Okay, so this is just a basic or an introductory tutorial that will give us a feel of what Nextflow is. So we're going to use Gitpod, which is an open source application that has that allows us to perform all these analyses in a cloud environment. So click on that. Click on that link, and then it will take us to the training page of Nextflow. So we're not going to install anything. We're not going to download anything, but instead we're going to use Gitpod 1.2. Okay, in this section 1.2, where we have Gitpod. So the pre-configured environment where we can easily run this command. So what you need to do is
Sorry, I'm just handing out stickies. People have just taken their part on with the stickies.
yeah. So once you're in the section, the Gitpod section, just hit the click that URL. Yeah. Okay. So we are in the main website for the course, right?
Yeah.
And then under Nextflow, you go to the hands-on exercises on your left, right? You click there, right? And then you will see a page. Yeah, basic tutorial. Click on that link where the first link, this one. You can open it in a new tab. Okay. And then it will take you to the Nextflow training page. Okay, it will take you to this page. Yeah. We all there.
So the reason why you don't want us to do it
But I'm going to ask you to
I know we'll have challenges. That's why. But this, I mean, the configuration and all those steps,
and also get some of the
just to save on time and make the. But you can follow the other steps if you want to install it on your local computer. You can follow the steps later. But for this purpose, let's try using this Gitpod, which has a Nextflow environment that has been pre-configured for this purpose. So are we there? If you're not there, just put a pink sticker.
Sure.
Can I ask everyone just to put up the green sticky if you're happy, and can you stop, please put up the pink sticky so that the trainers can see the output.
There's still no power. That power is because you can see this, that flag is on, that one is on. Sorry, so that one is not.
This one is never works, so you're using it.
Oh, is that cloud bomb?
Yeah, this private never works. That one also doesn't work.
Oh, that's good. They told us that they fixed the whole clouds. Sorry, so the first two clouds are not working. Okay. I'll report this.
Your power also went off. Power? So now power.
Things we can plug it in there.
Yeah, but we had everything at one point. That was dangerous and pure.
Are we on this page? If you're not here, just put a pin sticker. If you're there, put a pin sticker.
But it's fine, we will just have to look. Oh, the back two ones working,
Yeah, the back one.
and the front two ones are not working.
But they were working like. Yeah.
Which one's not working? Oh.
You guys all got power? Okay.
Great.
Just as with a show of hand, how many of us have programmed before? Any programming language? Right. So a couple of us have not programmed before. So there is some implicit assumption when we work in this Nextflow that some concepts are already familiar. That would include the loops, the conditionals, and so on. So I'm happy as we're going through, if you run into an issue, let me know, and we can also discuss that, maybe even over tea break, and that might break down the barrier a little bit, if it helps. But I'm sure as he's talking through, he'll be able to walk us through those constructs.
Good, so are we all on the Nextflow training page, right? So we're not going to do any local installation, we're not going to install any Docker because the option which you're using, Gitpod, has a pre-configured Nextflow environment that will allow us to do all these exercises without doing the installation. So there's section 1.2.1, Gitpod Quick Start. You can click on that link. You can open it in a new tab just to, okay. Then you will see a page like this, and it could be different. Yeah. If you're not there, put a pink sticker. If you're there, put a sticker. Are we all here? Put green if you're here. Put pink if you're not. It could be different, but you're seeing something like a workspace, right? Yeah, so so if it's a new workspace, so what it's going to do is that it's going to prepare that environment. And what that means, if there are any Docker images, it will go pull them. If there are any Conda environments, it will create them, okay? So it will take some time because it's preparing the environment for the workspace for you. So don't just be patient. Yes, so log in using those details.